Good evening, ladies and gentlemen. Welcome back to Dr. Pluring's very safe electronics laboratory. I've had a bit of thinking and done a bit of thinking really of what actually went wrong last time around here when that old power supply sort of blew up, or at least blew its fuse on me. And I think what happened, as I may have theorized too last time, was that as I connected the negative of the second boost controller to there, that one, that allowed for a different or a parallel return path for the current going out of this one, and thereby messing up its control thingamabobs and made it go over current or something. So that triggered the probably the under voltage protection in this thing. Since if you draw a lot of power, the voltage is going to drop and then it's going to turn off. And then what happened was that these two touched. And the way it is apparently here is that this heatsink, that is connected to ground, and ground is there is continuity all the way through. But this heatsink, that is not connected to ground. That is probably part of the positive side of the switching things. Because if I measure between negative and this, there is nothing. But if I measure between positive and this, there is something. And the meter behaves a little bit as if it was a MOSFET or something there. So when those touched, something happened which made the fuse in there go boom. And it also actually blew the fuse on my battery, right down there, the 15 amp fuse. So I don't quite know which blew first, or if they blew simultaneously, or if the fuse on the battery might have blown when I connected the second boost converter. I don't know. But I've now made a very, very unsafe repair. Not a repair even. Just replaced the fuse that was in here with something completely wrong, which you should never do. This is for a car. This is for DC low voltage, which I will now be using for fusing 250 volts there. But this is a 5 amp fuse, and the one I took out was 6. And as far as I understand, the main danger with using a DC fuse. No, it's rather the other way around. If you use a DC fuse for AC, if you use an AC fuse for DC, that's where you can get into trouble, because if the fuse were to blow and there would be an arc in between where it blew, for AC, when the AC does that, when it turns around not when it turns around, but when it crosses the 0 point, the arc may well be broken. But for DC, not quite such a thing. Concept exists, you know. So I have this hooked up now, and I have a remote power switch for it. And I'm not sure if this is going to work at all, because this is a carb fuse, blade fuse. Those are fast acting, and it's also lower rated than the original fuse. So it might not even be enough to charge the capacitors in the power supply. But nevertheless, I'm going to turn power onto it now from a safe distance, safe-ish distance. Maybe I should move away even further. So lots of things can happen now. The fuse can blow, and then we don't really know if that is due to charging capacitors or if it is because the power supply is screwed up. This fan, if the power supply does start working, this fan is going to start moving. Is that going to cause anything? Maybe. That if it starts up there, that thing will be powered, but that's not connected to the battery. Only the negative of it is, nothing else is connected to the battery. But I suppose we see right what happens here. If I can find the thing in, make my way through the menus here. There you go, leading plug 1, turn on. Whew, it works! Whew, okay. That's great. That is great. And do you want to, I think I want to check that's so very, very sketchy now. That is extremely sketchy. But the fuse is more easily replaceable now than it was previously. The power supply doesn't appear to be broken. All of these are positive things. But it's very sketchy to have it running like that completely without its cover and everything. And it's also very sketchy to use such a fuse for such a purpose, but whatever. For now, I want to measure that the voltage here, if that still is what the battery will like, 29.2. Yes. Okay. So you can have a look at the output of the charge or the battery management system, and see what happens when I connect the positive to there. Yes, we do get the charge. I'm going to connect that up in a more permanent manner. I'll leave this to it for a bit before I come back to it and continue experimenting. See if it is possible to use this in parallel or not, or if it's going to blow the fuse again, or if it's going to do something else. And really should put the cover on a little bit better there on the power supply. It's very, very unsafe now, but there are no children around, there are no animals around for the moment anyway, neither children nor animals. There's not even another grown-up around other than myself. I can hopefully keep from poking around in there. And as long as no one goes poking in there, nothing should happen. Right. You say okay. It stopped charging for some reason now. Why did you stop charging? But the fan is spinning, so the 12 volt out of the power supply should be okay. Maybe there's a bad connection. Oh. Well, what's the matter then? Oh, I see. The ground wires from the boost power supply, from the boost converter, they sort of came out. We turn that off, and I really should unplug it too, but alright. I'll connect this back up here. They were apparently not very securely connected. You need to strip them a bit more, mate, to get this to work at all. Yes, but this is temporary, as so many other things are. Ephemeral is what it is. That's a fancier way of saying that it is temporary or fleeting. There we go. That should be good again. Put the fan on it and turn the power on. Yeah, excellent. Maybe, yeah, it's charging. This light fluorescent thing is sort of making it a little bit difficult maybe to read. There you have it. I'll leave this to it simply for now, for a while. Anyway, we're pulling 156 watts from the wall, and according to the BMS, we're putting 117 into the battery. That's not very efficient. I think a lot of it is the power supply, which isn't getting the computer power supply. It isn't getting the cooling that is supposed to need it now. And when it is open air here, so the airflow won't get to be what it's supposed to be. Anyway, what do we have there? 25 amperes. 25. No wonder it's 25 amperes. What? That can't be right. No, but that's what it says. What's going on? Because that 25 amps. Okay. Then it might not be outputting 12 volts. What's going on here? Really? 25 amps, you say, meter? Are you really sure about that? 11.76. Well, if that's the case, I'm overloading it currently quite by a little bit. Because it was rated for that rail. Since I have it open now, I can actually tell which rail is which, and this rail is rated for 12 amps. Are you serious? There simply cannot be. No, seriously, this cannot be. 29 amperes. No, but this is all over the place. What the hell is going on here? No, this doesn't quite make sense. Yeah, no, this meter is not to be trusted, I'm telling you this. The BMS says 4.5 amps. This thing says it's 7. No. We zero it out and see what we get. Still getting 7. It says 7.7. What? Now this isn't making any sense whatsoever here. I'll let go of those. Release or reset if that's that does zero it out. Okay, that sounds more reasonable. 4 amps, sure. And zero again, please. 3 amperes. That's just not true. Nope, that's just not true. Now, according to the meter, we're getting 9 amps on the output, and we're drawing 23 on the input, which is not true. I don't know what is the okay, it hasn't been quite this bad previously. It has been inaccurate, but not this inaccurate. This is a joke. What is wrong with you? Three and a half. This is nothing now. We have nothing going through it at the moment. Okay. Put it around the ground leads there. 2. I give up for the moment. I'm sort of at least trusting the BMS there that we are indeed charging the battery with 5 amps or thereabouts. There's no way that the power supply could deliver double its rated output without turning off and engaging its under voltage protection or something like that. Yeah, that's it. I think I'll continue this later this evening or another day. Until then. We're continuing here, ladies and gentlemen. It's actually morning rather than I didn't continue this last night because the night sort of evening became night and got away from me before I had the chance to get back to this. However, just to check a little bit on how it's going here. I've actually charged the battery now for a while. It's up to 84% according to this. Still don't know what that is actually, but a bit of power has gone into it. A kilowatt hour or so has gone into it, and the cell voltage difference is down to 2 millivolts, even though I've not done any balancing. So yeah, but here we are now. I ran it on this one only then, as I left it when I stopped recording last, and now I've switched over to the other one. Still not running them in parallel or anything, just one at a time, seeing if that thing is working as it's supposed to, or what's going on. Yeah, so I'm going to start it here right now and see if it blows up or what happens. It did not blow up. It's not yet. Neither is it charging really, according to that. Alright then. And why would that be? I don't know, I suppose. No. Okay. Well, what the hell? I was not really supposed to get into this now, but since I've started, we might as well. Yeah, this is now officially the earliest recording ever that Dr. Pluring has made. What is it? 7:20 in the morning. It isn't even that early then. It's pretty damn early for Dr. Pluring. It's very early for Dr. Pluring. Yeah, but why aren't you charging or doing anything to it now? It ought to do something. Right, so apparently I'm doing this now. Yes you are. Yeah, you are. I was just going to switch it over to the second boost converter here and see that it worked. It didn't, so therefore supposed to be getting into it. Yeah, so it would appear. I have my coffee right here. Excuse me, ladies and gentlemen, while I just sip a little bit of coffee. Cheers. Okay. I suppose first order of business is disconnecting this here or somewhere. Anyway, you can disconnect it from there and make sure that it's nothing of those things touches or touch. Nothing of them should happen. Oh. Let's see what did I actually set this when I did it? Maybe I blew this up yesterday. Sure, mate, yesterday, whatever day it was when that happened. right. Turn it on. Yes. Do we have a voltage on the input? Yes, I think so. Yes, 12.0. Do we have a voltage on the output? 27.2, which maybe is just a little bit lower than. No. I think. Let's see if I can find the old notes. 27 points. I wanted to do 3.4 volts, right, for the different one, for the other one. There's a reason I don't record this early, or do a whole lot this early at all, and then make coffee and make sure to get that in me reasonably quickly. Yeah, 27.2 is what you wanted at. That is where it is at. Okay, well, maybe the current is simply set so low then that that's why it doesn't really charge. Yeah, it could be. Okay, I'm turning it off there whilst connecting and such here. And I really should get the cover back on the power supply and everything. Yes. There's always lots of stuff that you really should be doing. Yeah. There you go. Okay, so adjust current up maybe. See if I can get anything. That is the constant current adjustment. Yes, I'm sure. Oh, relatively. Sure. Oh, there we go, 0.2 amperes, 0.5. One point something 2. 3. 4. It is about the same as the other one, about-ish, at least. Now, I did learn something here last time, and that is that this cannot touch like so. But I need to cool both of them. Yes. So that's maybe a little bit sketchy. That's a little bit sketchy. Yes. Or I could, if I would have enough wiring to go around, and I could turn one of these here around, like so, then this heatsink and that heatsink should not be so dangerous for them to touch. Or I could maybe put an insulator in between or something. Yeah, maybe you could. Okay. See here, connect that there. It might blow again. It may well blow again. It may blow when I turn the power on. It may blow. Oh, I don't know. It might blow now then. So now I'm going to connect it there. Right. Okay, I can place you over the exposed, dangerous high voltage. Yes. Okay, touch that. Just touch it first to see if something blows up. Okay, nothing happened. Nothing should happen. Neither. Okay. Little bit of a spark. I think that you usually get a little bit of a spark when you connect these things up. These here boost converters and whatnot. because they have capacitors in them that charge what they do. Because as of right now anyway, no current is flowing according to BMS. There are those two, and that should be most of the things that could go wrong in the shot. It's a little bit dark over there where the power supply is. You could try maybe, yeah, maybe I could. It's a little better. It should be a little bit better, right? It's not worse. Yes, you can maybe do this too. I don't know if that was an improvement, mate. No. So you say insulator in between these, so that I can put the fan on somewhat there. So something that's non-conductive, just to put in between, and also small enough to still allow the fan to reach both an old snusdosa. It's too large, possibly. Or I think it's going to vibrate this fan now, and maybe not quite, something much smaller. An empty, almost empty roll of electrical tape. So now this has come loose here. Yes, indeed, there are reasons why I don't do this early, or much of anything this early, other than drink coffee, as I said here. Not have the greatest of morning moods. Not have the greatest of moods overall, but in the morning it is significantly worse. Any other time of the year, yes, every morning is worse than every other time of the year. Yes, especially in winter. But yeah, that fan will only really be blowing on one of the heat sinks. Okay, it will blow up immediately anyway. It won't work, this. Yeah, right. No. The power supply went into protection mode. It did blow its fuse, which is a good thing, because it doesn't work anyway. Oh, you can forget about this, apparently. Yeah, so it would appear. For some reason that I cannot quite explain just now why it wouldn't work to have this in parallel without tripping the protection on the power supply. I don't know. I do not know, but now that it is the other one is disconnected there, can we turn it on? No, didn't the fuse blow? No, the fuse is intact. Maybe it needs a while longer to reset itself or something. Really. That's interesting. Isn't it just? Do you reckon the fuse blew on the BMS or battery? No, not the BMS, the battery. I don't think why would it? Because nothing happened really. Or did anything have time to happen? No, that fuse is intact. This fuse at least looks to be intact. Oh. Okay then. Do you need a little while to reset after you have had a under voltage event? I don't know. I don't think so. I need to disconnect these and connect them back together, or just leave it for a minute. Have some more coffee. Right, but we have learned then that it is not possible to just, at least not as simply as this, connect two of these here in parallel. Not much we've learned, and because if you do that, it trips the your power supply. If it has a tripping effect, if it has the ability to trip itself rather than destroying itself, or it will blow a fuse or something. But also if you connect the heat sink of maybe the voltage limiting MOSFET, if that's how these work, I don't know how they actually work. But if you touch that heat sink to that heat sink of the other one, are you making sense, mate? I don't know, it's too early. There you go, it's working again. Charging at 4 amperes. So yes, indeed, it requires a little bit to reset. As if it will trip the power supply if you connect that again. Apparently, yeah. There you go. I don't know if that's the conclusion to this one, or if we'll get back to experimenting a little bit. I will leave this to charge for a while at all of 4 amperes, and we'll continue later maybe. Yes there, ladies and gentlemen, it's been a few days since I was last here. This is like the sketchiest thing I've ever done, I think, as far as electrical things. Yeah, man cold is still a thing, but the battery is now more or less fully charged. Here, as a matter of fact, see if we can bring you in. Also, it is. If you wouldn't do that, maybe. There you go. We have a voltage now of the battery of 28.28 volts, more or less, with a cell voltage difference of 10 millivolts or so. So the cells are pretty much, they have balanced out here. I've charged it at about the rate of maybe 6 amperes or so for a while until it got to this point, and now we're almost fully charged. The cells are resting at about 3.53 and so on. I'm going to turn the voltage up slightly to see if we can hit like 3.65 on one or a few more cells. So I've charged it slowly, and I've charged it even slower at a lower voltage here to give the balancer thing its opportunity to do its thing and balance the cells out, and I think it's done a pretty decent job of it. Number 3 here was hit 3.65 volts way before the other ones, and it's been now balancing backwards and forwards for a bit. And I think it's gotten to a point where they are pretty much in balance. So I think what remains is to do the last, just get them up to maximum for one time. Now, but this is the sketchiest thing I've ever done. One of the sketchiest things I've ever done. I moved the fan out here to get better cooling. Turned out that the fan was also had a voltage control on it, so it moved really slowly for some reason, even though these heat sinks were really damn hot. So I took that out, I put that fan directly on 12 volts, so it actually does something now, and it cools that off pretty efficiently. But this is very sketchy, but it seems to work with this fuse. But it's not recommended to run this without the covers on, I can tell you very much. Because I can show you one thing. Well, before I show you that, I'm going to turn the voltage up so to get the last bit into it. So now it is resting there at about 28.28 volts or something such. And 29.2 is if all the cells are at 3.65 volts. So let's get it, try and get them sort of close to that there. I turn off charging for a little bit there, and hook up my voltmeter here. Maybe I should use the voltmeter I actually trust, because this thing is hopeless. At least the current measurement of it, which is the reason I bought it, because I wanted a clamp current meter, and of course I wanted a cheap one. So this is a cheap one. Buy cheap, buy twice, as they say. It's very much true. I think you can almost see the display of it if we just move the leads out of the way there as well. Yes. There we go. Hook up the probe to the negative there, and to the positive there. Is that enough? Yes. So 28.25 is what it is outputting, and it's just in the glare of this thing. If I turn this off, does that get it? Yeah, that made it a whole lot better. Great, right. A little screwdriver. Hold on. We're not going to be able to get all the cells up to 365, but at least maybe some of them. And if it's prudent or something that very important. I mean, they are as close to fully charged as they are very close to fully charged as is. But about there, 29.1, 15, 29.13. There you go. And we turn the charging on again there. And see what we get. It's back to putting 6 amperes into it. Yes, but pretty quickly one or more of the cells here is going to jump up to the 365 limit, and then the BMS will stop accepting current for it, and so on. Yeah. So, yeah. You see the current is already going down, so it's very close to being fully charged. But yeah, so there you have that. Let's see what happens. This now cell 1 is apparently the lowest one at 3.602 volts. 3 is again the highest one, so it hasn't balanced it out maybe perfectly. But I don't think that you'll get a perfect balance the first attempt. But this will it will balance every time it charges, or every time the voltage of the cells is higher than what I set it for here. Start balance voltage I set it to 3.4. Don't know if that's prudent, but it seems to me that it's no use trying to balance the cells when they are in there, the flat bit of the curve. You need to be outside of that flat bit too, otherwise it's just going to move current about, charge about between the cells, and don't really know what it's doing. And I got about see here now, the I have on the power socket there, I have that thing that can measure power, and that has measured about 4.6 kilowatt hours maybe, and I calculated the efficiency of this thing to be about 80% at a decent load. If you do a very small load such as now, when it's only putting 1.4 amperes into the battery, then the efficiency of the power supply is like 50% at best. But the bulk of it, I reckon I got about 3.5 kilowatt hours into the battery, give or take, maybe a little bit more. So that would indicate that they shipped them at about maybe 10-20% state of charge, which seems, maybe that's, I think that's reasonable. If I remember correctly, somewhat correctly, that's what it said in the data sheet of the cell manufacturer, that you should store them at long term. So that would make sense. Pardon me, I need to blow the nose there a bit. If I had something to do that into, just a moment. There we are. Right, we'll just go over a little bit just how sketchy this thing is. You see, it has already gone down to only 0.7 of an amp here for charging current. So it is, yeah, they are pretty much, it is pretty much fully charged. So it's time to start discharging it. Yeah, I'll go set that up and go over what I intend to use for discharging and so on next time, next installment. No, let's just look a little bit closer at what we actually did here. Yeah, but you already went through this. But it's very sketchy, because, for example, you might want to feel how warm this is, which is fine. This one is fine. That one is also fine to touch if you only touch that one as it is. However, don't ask me how I know this. I can show you by measurement. Here, if we do an AC measurement, can you read the display? Not really. Ground and the heatsink. That's 125 volts AC there, which can be a little bit tingly. Don't ask me how I know that, as I said. Well, this is so incredibly sketchy. No, I don't like it very much at all. But it's only been like this to get to charge the battery and to be able to change out the fuse. But this seems to be working with that fuse, so I think I'll leave it like so. Might want to try and look into getting a little bit higher voltage out of this one. Could be interesting. Maybe. Might be something I want to do eventually. But that's it for the moment, because now it is charged. The battery, more or less, anyway, very close to being charged. We're at 29.10 volts. And this cell is really close to getting to the 3.65 thing. What did I actually set the power supply to? 29 point. Didn't quite go all the way to 29.2, so we're not going to get, since they are very equal here now, you're going to find it difficult to get them up to 365. Okay, well, we do it again then. We adjust it again slightly. Turn off charging. Turn off charging. Cheap piece of crap, this impulse buying Samsung something or other. Yes. Yeah, the price might have been good, but the performance is I mean, it's about on par with my iPhone 8, or even a bit slower maybe than my iPhone 8. 29.13 we're at. So just adjust it up ever so slightly. $29.2 exactly according to this meter. Yes, and according to a maybe more proper meter, I don't know, Velleman, you know, this is very old, and it isn't so fancy, but I think that it actually is a pretty decent instrument for what it is. Cheap and so on, but not cheap as we would call cheap today, because this is from the 90s. I got this in 90, what would it have been, 97. No, we need to go there, and then we'll lose one decimal of resolution, unfortunately. 29.2. Okay, they seem to be in agreement. Excellent. Cooling back on, and also then turn the charging on and see what happens there. 2.3 amperes, not a lot. 3.626 is the 3.3, and they are very close together now, the cells, so that's good. And what has it been? Today is a Sunday. The first time I put charge into this was Wednesday, Thursday, and I've not been running it all the time because I want to be awake and be at home when this very sketchy thing is on, as it stands right now anyway. So that's why it's taken a few days to get it up to this level, and also I've only been able to charge it at about 160 watts in total. As the voltage out of the power supply is low, and I'm limited by the capacity of these here boost converters on the input. 15 amperes of maximum rated input, and I've been running it at about 12-13 maybe. See if we can see. No, we can't, because we're not. There you go, battery is fully charged, it says. Yeah, and it was cell number 3 as usual. So maybe it isn't fully balanced yet, because if it was, I would, if it was completely balanced, that is, I would expect the cell that is hits 3.65 first to be not the exact same cell each and every time, but rather move around a little bit. I think it's close enough, you know. So there it is. I'll leave it like this for a bit, and then I'll disconnect the charger and everything, and get this all this incredibly sketchy stuff out of the way. I'm going to install this fan back in there, but have it the other way around from where this factory, since it is a PC power supply, is trying to suck air out, which makes sense when it is in a PC case. But in this case, I'm going to get more efficient cooling, I think, if I have it rather blowing air onto all the components here, and then that will make it out of there, hopefully. And also running at full speed, regardless. I don't know the temperature control in this thing, if that's working at all, since it was quite hot and the fan was running at like nothing, basically. Okay. Well, Dr. Pluring's battery is charged, as we can see, at 28.9298 volts. Eventually, when the cell, as I've set it now, if they settle back to 3.5 volts, it will enable charging again. Right now it's still balancing though, but it's just on the limit where it will balance. It's set to a cell voltage difference of 10 millivolts to engage balancing. I don't know if it makes sense to go any lower than that, because the measurements aren't going to be 100% accurate for each and every cell. But it seems as though first of all the cells came very well balanced from the seller. So far all I have been able to see about the cells and so on is that I went with a good supplier. They are genuine EVE cells. The QR code and everything matches. They came really well balanced. There were only a few. It was only this cell basically. There was a few millivolts, maybe 20 millivolts or so. No, 100 millivolts or so more than the other ones when we reached the top of the state of charge thing. So yeah, I can't complain about anything there. I'm very happy with the battery cells as it stands. The only thing I'm not very happy with regarding that was that the shipping was so goddamn expensive. But yeah, and the BMS, I'm pretty happy with that as well. So far, it seems to be doing its thing. Still with the setup as I have it now, I'm only going to be able to test low current, as you've seen previously. Later on, I will build it properly with thick cables and such, and then maybe be able to do some more high capacity, high power testing of it. But I don't know, I don't have a really strong DC load to put on it. I mean, I can continue doing stuff like this, soldering halogen bulbs together. Or I could get myself an AC inverter, like a 2-3 kilowatt one, but that's expensive, and I'm still not sure about if I want that in the caravan or not. It depends on a lot of things, which I'm not going to be able to figure out until springtime when it gets a bit warmer outside, and so on. So there you are for now. Dr. Pluring's battery is now charged. And he has done some sketchy things to get it to this point. I'm going to try and reverse some of the sketchiness here. Thank you so very much for watching. This was number 7 maybe in the series of battery building and now charging. Cheerio.